Hi Algebra 2, this is Unit 3, Lesson 2, and today we're going to talk about average rate of change. So the first example we're going to look at or talk about is a linear function. A linear function is a line, and for a linear function, the average rate of change is basically just the slope. Remember back in geometry, slope was m, it was a change in y over change in x. So I have that right here. The average rate of change is really just the slope. Change in y over change in x, meaning you're going to do y2 minus y1 over x2 minus x1. And you can see that no matter where I do the slope, so if I'm doing the slope right here, change in y over change in x, that slope is 2 over 1. And if I do the slope down here, same thing, 2 over 1. So the slope is constant. That's important to remember. So for a linear function, it doesn't matter which part of the line, that slope or average rate of change is always going to be the same. Now that's different for our nonlinear function, and that's where it gets a little bit trickier. So for nonlinear functions, the average rate of change is not constant. You are finding how fast the function's y values, that's your outputs, are changing compared to the function's x values, and that's my input. So let's look at this. The average rate of change for a function y equals f of x between x equals a and x equals b. So I have to tell you which part of the function I actually want to find the average rate of change for. The average rate of change is the change in y over the change in x. How do I figure that out though? It's f of b minus f of a over b minus a. So for nonlinear functions, that average rate of change is not constant. You have to say which interval you want to find the average rate of change over. It's still the change in y over change in x, but it's the change in y at that particular interval over the change in x at that particular interval. All right, so remember that y equals f of x, so our slope or average rate of change can be expressed as y2 minus y1 over x2 minus x1, or a little bit fancier for our nonlinear functions, f of x2 minus f of x1 over x2 minus x1. So if we're looking at this parabola here, and again, there's not anything to write down. I'm just trying to explain this, and then we'll get to a question in a second. But you can see the slope is not constant. If I'm doing the slope between interval from 1 to 2, let me just move this up and get my highlighter. So if I'm looking for between 1 to 2, the change in y is 3 and the change in x is 1. So that slope is 3 over 1, whereas I'm looking for the interval between 0 and 1, the change in y is 1 and the change in x is 1, that has a slope of 1. So depending on where you are, I have different slopes. The slope is not constant. All right? So let's look at an actual example that we'll try together. So example 1. I want to determine the average rate of change of y equals 0.8x plus 1 over the interval from 0 to 10. All right, so here's what you need to do. You need to find f of 0. So I'm plugging in 0, 0.8 times 0 plus 1. Now 0.8 times 0 is 0 plus 1 is 1. And I have to find f of 10, which is 0.8 times 10 plus 1. 0.8 times 10 plus 1 is 9. So I'm going to do f of 10 minus f of 0 over 10 minus 0. So 9 minus 1 over 10. Okay, again, where did I get those from? This is my f of 0. This is my f of 10. I already previously figured out what those were. And then 9 minus 1 over 10 is 8 over 10, which is 4/5, which is, this is a linear function, so that actually is equivalent to 0.8. Remember, y equals mx plus b. So I'm showing you how to do it, but this is actually a linear function, this example. I did not have to do it out, but this is the way that we're going to do it for nonlinear functions. All right, example 2, we're going to be looking at a chart. Each day, Joe records the height of a basil plant for his science lab. His data is shown in the table. So I have days across the top, 1, 2, 3, 4, 5, and I have the height across the bottom, 3, 4.5, 6.1, 7.4, 8.9. What is the average rate of change in height per day of the plant from day 1 to day 5? So I'm going to figure out the height at day 1 and the height at day 5. So at day 1, my height is 3. At day 5, my height is 8.9. So my average rate of change is going to be h of 5 minus h of 1 over 5 minus 1. Well, h of 5 is 8.9, h of 1 is 3 over 5 minus 1. So that gives me 5.9 over 4, and I'm going to just do this 1.475. And that is my average rate of change. Okay, so we're talking about that's my height. The average rate of change from day 1 to day 5 is 1.475. So this formula, if you want to call it a formula, works for nonlinear functions. And again, what am I doing? I'm doing this right here. I'm doing f of b minus f of a over b minus a. And a and b are basically the interval that you are finding that average rate of change for. All right, let's look at one that's on a graph. So the function f of x is shown graph to the right, and some of you I know are having a little bit of trouble with the graphs, reading them. Evaluate each of the following based on the graph. So f of 0, so this is just, remember, f of x. So the 0 is my x. So on the on the x line, go to 0 and go up. It's this point right here, 0, 1. So f of 0 equals 1. F of 4, 1, 2, 3, 4 is this point right here, which is 1, 2, 3, 4, 5, 6, 7. So this is the point 4, 7. So f of 4 equals 7. See how I'm reading the graph? F of 7 is going to be this next one right here. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the point 7, 10. So f of 7 is 10. So my input is 7, my output is 10. And f of 13 is this last point right here. And it's 13, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See how I'm just counting to see what the y is. F of 13 is 15. All right, now that I have that, I'm going to find the average rate of change over the intervals. I'm going to try 3 different intervals. So the average rate of change when x is between 0 and 4 is going to be f of 4 minus f of 0 over 4 minus 0. Well, we know f of 4 is 7, f of 0 is 1, and 4 minus 0 is just 4. So this is 6/4, which is just 3/2. Okay. The next one, I want to know the average rate of change between 4 and 7. So that's going to be f of 7 minus f of 4 over 7 minus 4. Well, f of 7 is 10. I have all those values up above that I'm looking at. F of 4 is 7, and 7 minus 4 is 3. So this is just 3 over 3, which is 1. And this last one, I want to know it from the interval from 7 to 13. So I'm doing f of 13 minus f of 7 over 13 minus 7. Well, f of 13 is 15, f of 7 is 10, 13 minus 7 is 6, so this gives me 5, 6. Okay? Last part for this question. Using a straight edge, draw on the line whose slope you found in part D by connecting the points shown in the graph. The average rate of change is a measurement of what property of the line? Okay, so the average rate of change or slope measures how steep the line is that connects the 2 points of the function. So let me draw that line, although it might be a little bit hard because I don't have a ruler here. But the average rate of change, just so you understand this, the average rate of change or slope measures how steep the line is that connects the 2 points of the function. All right, so basically I'm taking a ruler and I'm connecting. I will try and draw that as best I can without a ruler. I don't think I have, no, I don't have a ruler here. And I'm just going to connect this one and the last one right here. All right. So the average rate of change is the measure of how steep the line is that connects the 2 points of the function. All right. You can also use your calculator to do this if you want to, but you would have to do stat. You hit stat, write 4, enter, 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 and you would put in, you put in that table for x1 and x2, and you're putting in your points. Okay, that's another way to do this. We can talk about that in class. Example 4, during which interval is the average rate of change the greatest? Okay, so is it the greatest between -4 and -2, between -2 and 2, or 2 and 4? Well, I would have to figure out what it was between each interval. So if I'm trying to figure it out between -4 and -2, I'm going to find f of -2 minus f of -4 over -2 minus -4. All right, because I'm always doing my x2 minus x1. F of -2 is -2, because here I am, -2, it's -2. F of -4 is also -2, but I'm subtracting those, and -2 minus -4 is actually 2. And on top, that's 0. And that makes perfect sense because I'm doing it right here. Is that increasing between those 2 points? No, that is a horizontal line. That is a slope of 0. Now I'm going to try that next one between -2 and 2. So I'll do f of 2 minus f of -2 over 2 minus -2. F of 2 is 2. F of -2 was 0, -2, sorry, so 2 minus -2, and 2 minus -2 is 4. This is also 4, and 4 over 4 is 1. So I'm talking about the slope right here has a slope of 1. And then my last one, we're doing from 2 to 4. So I would do f of 4 minus f of 2 over 4 minus 2. F of 4 is down here at -2. F of 2 is up here at +2. Again, I'm subtracting them. And 4 minus 2 is 2. So this is -4 over 2, which is -2. So those are my average rate of change over each of those 3 intervals. So which one has the, and I got a line there somehow, I'm not sure how that happened. Which one has the greatest average rate of change? So I don't care about negatives and positive, I want that biggest number. So between 2 and 4, that is the steepest. It has the greatest average rate of change. Okay, and then we just have a few more on the next page. Given the function f of x equals -x squared plus 4x minus 1, find the average rate of change from x equals 1 to x equals 5. So you have a choice on this. You can use your calculator to find these rates, but I'm basically going to do f of 5 minus f of 1 over 5 minus 1. So your choice is you can find f of 5 algebraically by plugging in 5 for x. Okay, that's one way to do it. And then finding f of 1 algebraically by plugging in 1 for x. Okay, and find out what each of those are. Or you can use your calculator. So on your calculator, which you guys might find a little bit easier, you definitely want to have a calculator or the calculator app on your phone. So I'm plugging this in, and then I'm looking at my table. Okay, so my table now, I really just want to know what when x is 1 and when x is 5, what those y values are. So you can do it algebraically for sure, or you can plug it into your graphing calculator. Let me see, I should have my graphing calculator right here. So I calculate 84. I go to y equals, and I'm doing -x squared, Okay, what was it? Plus 4x minus 1. And then I'm going to hit second table, right there above the graph. And I want to know the values of when x is 1. Well, when x is 1, let me scroll down right here. When x is 1, y is 2. And then I also want to know when x is 5. When x is 5, y is negative 6. All right, so if I'm going back to my, so at x is 1, y was 2. And when x was 5, y was negative 6. And I would get those same values if I was doing it algebraically up here. I would have gotten negative 6 and 2. Okay, now that I have that, I'm figuring out, I'm going back over here. So f of 5 is negative 6 minus f of 1 is 2, and 5 minus 1 is 4. So that's negative 8 over 4, which is negative 2. Okay, what does this tell you about the graph of the function over that interval between 1 and 5? Since it is a negative average rate of change, that graph is actually decreasing. All right, next one, I already have a little graph that I'm looking at. An object travels such that its distance d away from its starting point is shown as a function of time t in seconds in the graph below. What is the average rate of change of d over the interval when time is between 7 and 5? So basically I'm going to do f of 7 minus f of 5. Oops, let me just minus f of 5 over 7 minus 5. Well, let's find f of 7 is right here. F of 7 is 64. F of 5 is down here. F of 5 is 20. See how I'm getting those numbers? So 64 minus 20, and 7 minus 5 is 2. Well, that's 44 over 2, which is 22, and I'm talking about feet per second. See how the feet and the second? So 22 feet per second. B, the average rate of change of distance over time, what you found in part A, is known as the average speed of an object. Is the average speed of this object greater on the interval between 0 and 5 or between 11 and 14? Justify. All right, so basically I need to find the average rate of change between, let me grab a different color. I'm going to find the average rate of change when the time is between 5 and 0. So f of 5 minus f of 0 over 5 minus 0. So f of 5 again is 20. F of 0 is 0. And 5 minus 0. So this is 20 over 5, which is 4 feet per second. So I'm looking at this right here. And then I'm looking at between 11 and 14. So I'm going to do f of 14 minus f of 11 over 14 minus 11. F of 14 is right here, that's 79. F of 11 is right here, that's 64. 14 minus 11 is 3. 79 minus 64 is 15 over 3, which is 5 feet per second. Okay. And so I want to know which is the greater interval. Actually, the one that gave me 5 feet per second is, so the greater interval, or it's greater over the interval, I should really say. Greater over the interval when t is greater than or equal to 11 or less than or equal to 14. So that has the average rate of change, the larger